History of Ruby on Rails. Ruby on Rails, often referred to as Rails, is a web framework written in Ruby under the MIT license. It is designed to make the development of web applications simpler and faster through the use of conventions to avoid extensive configuration. The command gem install Rails installs the Rails gem, which is a package necessary to create and work on Rails applications. This command symbolizes the beginning of a Ruby on Rails journey. Rails was created in 2003 by David Heinemeier Hansson, and it was later released to the public in 2004. Rails emphasizes the use of well-known software engineering patterns and principles, such as active record pattern, convention over configuration, COC, and don't repeat yourself, DRY. Rails philosophy: convention over configuration. Convention over configuration is a fundamental principle in Ruby on Rails, designed to simplify development by setting sensible defaults that align with common tasks. Instead of specifying intricate configuration details for every aspect of the application, Rails assumes sensible defaults that most developers would choose. This allows developers to focus more on unique application logic rather than boilerplate setup. In this example, Rails infers the table name as books from the class name book, following the convention that table names are pluralized class names. There's no need for explicit configuration to link the book model to a books table, demonstrating convention over configuration. This principle significantly reduces the amount of code needed to configure a Rails application, making development faster and less error-prone. MVC architecture. MVC, which stands for Model View Controller, is a design pattern that helps separate the application into three interconnected components. This separation makes it easier to manage and extend the application. Rails is strongly based on this pattern, facilitating a structured way to build web applications. In this snippet, the articles controller acts as the controller component of MVC. It handles the user request to show a specific article. By calling article.find params ID, it interacts with the model, which is responsible for managing the application's data. The model fetches the requested article from the database. The @article variable then becomes available in the view, which will be responsible for displaying the article's data to the user. This code demonstrates how the MVC components interact. The controller receives user requests, consults the model for data, and passes that data to the view for presentation. How Rails works: the basics. Ruby on Rails, often just Rails, is a web application framework written in Ruby. It follows the Model View Controller (MVC) architecture, aiming to simplify the coding of web applications by making assumptions about what every developer needs to get started. Let's explore a basic example of how a Rails application handles a web request. In this example, Books Controller is a controller class that inherits from Application Controller. When a user requests the /books URL, the index action method within this controller is called. The @books instance variable is set to the value of book.all, which retrieves all book records from the database using active record, Rails ORM. The MVC architecture then proceeds to render a view, typically index.html.erb for this action, which will display the books to the user. This demonstrates how Rails processes a web request by moving through the MVC components, receiving the request, processing it in a controller and model, and then presenting it in a view. Installing Ruby on Rails. To get started with Ruby on Rails, you first need to have Ruby installed on your system, along with several other dependencies like Ruby Gems, SQLite 3, Node.js, and Yarn. Rails can then be installed as a Ruby gem. Below, we showcase the typical commands used to install Ruby on Rails on most systems. This command is used to install Ruby on Rails via Ruby Gems, which is a package manager for Ruby. When executed, it fetches and installs the Rails gem and its dependencies. It's a straightforward way to get Rails up and running on your machine. After installation, you can verify by running rails-staff version to see the installed version of Rails. Note that Ruby must be installed before this step. Setting up a development environment. To start developing with Ruby on Rails, you first need to set up your development environment. This involves installing Ruby, Ruby Gems, Rails, and a database such as SQLite 3 for starters. This guide will focus on a Unix-like environment, such as Linux and macOS. Windows users might need to perform additional steps or use a compatibility layer like Windows Subsystem for Linux, WSL. The code snippet details the basic steps for setting up a Ruby on Rails development environment on a Unix-based system. Sudo apt-get install Ruby full installs Ruby. Sudo gem install Rails installs Ruby on Rails. Rails new My First Rails app creates a new Rails application named My First Rails app. cd My First Rails app changes the directory to your newly created application. Bundle install installs all the gem dependencies for your application. Finally, Rails server starts the Rails server, allowing you to access your application through a browser at HTTP localhost 3000. This sequence gets you from installation to having a running Rails application. Creating a new Rails application. Creating a new Rails application is the very first step in building web applications with Ruby on Rails. This process sets up the necessary directory structure and configuration files to get started with development. Let's see how to do this. The command Rails new my app initializes a new Rails application. Rails is the command line tool for Ruby on Rails. New is the command to create a new application, and my app is the name of your application. This command creates a directory named my app with all the necessary files and directories for a Rails project, including a new gem file for dependencies, a new database configuration, and the initial MVC, Model View Controller structure. This is your project's starting point, where you can start building your application's specific functionality. Directory structure of a Rails application. Understanding the directory structure of a Rails application is crucial for developers. It helps in navigating the project, organizing code logically, and adhering to the convention over configuration principle. Let's dive into the basic directory structure of a standard Rails app. A Rails application includes several directories and files, each serving a specific purpose. The app directory contains the models, views, controllers, helpers, and assets for your application. Config/ holds configuration files for routing, database, and more. db/ is where your migration and schema files live. bin/ contains executable files. lib/ is meant for extended modules and classes. log/ stores application logs. Public/ holds static files and compiled assets. Test/ or spec is where tests are written, depending on whether you're using Minitest or RSpec. Understanding this structure is fundamental in effectively navigating and developing a Rails application. Syntax and basic constructs. Ruby is known for its elegant syntax that is natural to read and easy to write. Let's go over some basic constructs, including variables, data types, and operators. In this code snippet, we define a variable age and assign it a value of 18. We then use a simple control structure called the ternary operator, which acts as a compact if-else statement. The condition before the question mark checks if age is greater than or equal to 18. If true, you are an adult is printed. Otherwise, you are a minor is displayed. This demonstrates basic variable assignment, comparison operators, and a concise way to execute conditional logic in Ruby. Data types and variables. In Ruby, variables are used to store data which can be of different types, such as numbers, strings, arrays, and more. Let's explore the common data types and how to use variables. In this code snippet, number is an integer variable storing the value 10. Float is a floating point number storing 20.5. String stores a sequence of characters, hello Ruby. Array holds a collection of items of different types, in this case an integer, a string, and a float. Lastly, hash is a collection of key-value pairs, where key is associated with value and number with 10. Variables in Ruby are assigned using equals, and the type of the value they store is determined dynamically at runtime. Control structures, if-else loops. Control structures allow a program to make decisions or repeat actions. The if-else structure directs which block of code runs based on a condition. Loops, such as while and each, repeat code for set conditions or over elements. This example showcases two control structures. The if-else checks if temperature is more than 30. If true, it prints it's hot. If false, it prints it's not too bad. The times method is a loop that repeats a block of code. In this case, printing Ruby loops are fun, 3 times. Both structures guide the flow of execution based on conditions or repetitions. Methods and blocks. Methods in Ruby are defined to perform a specific task. They can take parameters and return values. Blocks, on the other hand, are chunks of code enclosed between either braces or the do-end keywords. They can be passed to methods and are a fundamental concept of Ruby's approach to coding. In the code example, a method named greet is defined, which takes name as a parameter and prints a greeting message. The method is then called with Alice as an argument, executing the code inside the method. The block example shows how to execute a piece of code multiple times using Ruby's times method. The block puts hi there is executed 3 times, demonstrating the principle of passing blocks of code to methods in Ruby. Classes and modules. In Ruby, classes are blueprints for creating objects, encompassing methods and properties. Modules, in contrast, are collections of methods and constants that cannot instantiate objects, but can be included in classes to mix in functionality. This code defines a person class with an initialize method to set the name and an introduce method to greet. The greeting module provides a say hello method. The student class, inheriting from person, mixes in the greeting module. By including greeting, student instances can use say hello. When a student object is instantiated with the name John, calling introduce returns a personal greeting, while say hello utilizes the mixed-in module method for a general greeting. Exceptions handling. In Ruby, exceptions are a way to handle errors or unexpected events that occur during the execution of a program. Using exceptions handling, a program can gracefully manage these situations without crashing or producing incorrect results. The process involves encapsulating potentially problematic code within a begin, rescue, .end block. This code attempts to divide 10 by 0, which would normally cause an error. The begin block encapsulates the risky code. When the division by 0 is attempted, rather than crashing, the program rescues this specific type of error, zero division error, and executes the code within the rescue block, printing attempted to divide by 0. If no errors occur, the else block is executed. Regardless of the outcome, the ensure block ensures. This code runs no matter what, gets printed, demonstrating a comprehensive approach to handling and recovering from errors. Working with files. Working with files is a crucial aspect of programming, allowing for data persistence beyond the runtime of a program. Ruby makes file operations straightforward, incorporating methods to read, write, and manipulate files with ease. Here, we will learn how to create a new file, write to it, read its content, and finally close it. This code demonstrates creating a new file named example.txt and writing the text "Hello World" to it. The W option in file.open specifies that the file should be opened for writing. The block provided to file.open ensures that the file is automatically closed after the block executes. File.read is then used to read the content of example.txt, storing it in the variable content, which is subsequently printed to the console. This example showcases basic file operations in Ruby, emphasizing how blocks can manage resource cleanup, like closing files automatically. Basic debugger. In Ruby, debugging is crucial for identifying and fixing errors or bugs in your code. Ruby provides several ways to debug a program, one of the simplest being the use of p or puts to print variables or expressions to the console. For more sophisticated debugging, the debugger gem or bybug in newer versions can be integrated into your application, allowing you to set breakpoints, inspect variables, and step through code execution. In this example, we define a method factorial that calculates the factorial of a number recursively. To debug, we introduce a Boolean variable debug. When debug is true, it prints messages to the console at the beginning and after calculating the factorial, helping us understand the flow and the intermediate results. This simple method is useful for catching errors or understanding how your code executes at runtime. However, for more complex debugging scenarios, the use of dedicated debugging tools is recommended. Using IRB, Interactive Ruby. Interactive Ruby Shell, IRB, is a tool to interactively execute Ruby expressions from the command line. It is useful for testing small code snippets, learning about Ruby's features, and experimenting with the language in real time. To start IRB, simply type IRB in your terminal. In the code example, after entering IRB by typing IRB, we perform a basic arithmetic operation, 2 plus 3. The symbol indicates a prompt where the user can input Ruby code. After typing the expression and pressing enter, IRB evaluates the expression and displays the result, which is 5 in this case, preceded by equals. This demonstrates IRB's capability to instantly execute Ruby code and show outcomes, making it an invaluable tool for beginners to explore and understand Ruby's syntax and behavior dynamically. Active Record Basics. Active Record is the M in MVC, Model View Controller, which is responsible for handling the data and business logic of the application. It facilitates the creation and use of business objects whose data requires persistent storage to a database. In essence, Active Record ties the database table to a Ruby class, making it possible for you to query and manipulate your data within the database using Ruby code. It abstracts complex SQL queries and allows you to interact with the database in an object-oriented fashion. This feature significantly speeds up development time and reduces the amount of boilerplate code you need to write. Migrations. Migrations are a feature of Rails that allows you to evolve your database schema over time in a versioned manner. Instead of writing SQL directly, you define changes in a Ruby DSL, making your code database agnostic. In this migration, createArticles is a class inheriting from Active Record migration with a version number. The change method defines what changes to apply to the database. Here, it creates a new table called articles with columns: title, string type, and body, text type. The t.timestamps line automatically adds created at and updated at columns to track record creation and update times. This code doesn't have to be modified to run on different database systems, thanks to Rails abstraction. Validations. Validations are crucial in ensuring that only valid data is saved into your database. They are used to enforce data integrity and business rules on the model level. Rails provides a variety of built-in methods to validate model attributes before they are saved, helping to prevent errors and ensuring that only expected values are stored. In the provided code, 3 validations are set on the user model. The first validation ensures that the name attribute must be present for a record to be valid. The second validation also mandates the presence of the email attribute and, additionally, requires its uniqueness across all records, preventing duplicate email addresses. The third validation enforces that the age attribute must be a number less than 120. These validations are automatically checked before the model is saved to the database, and if any are not satisfied, the save operation will fail. Associations. In Rails, associations are used to set up relationships between different models. For instance, if a blog has many posts, Rails allows you to set up this one-to-many relationship easily. Associations use simple configuration to make operations on related objects much more convenient. In this code, we define a blog model that has many posts, meaning a single blog can have many posts associated with it. Conversely, the post model belongs to blog, indicating each post is associated with one blog. These association macros add methods to the models that facilitate the management and querying of these relationships, such as enabling us to easily fetch all posts belonging to a specific blog. Query interface. The query interface in Rails provides a powerful way to interact with the database using Ruby code instead of writing raw SQL. Models in Rails use this interface to create, read, update, and delete database records easily. Here, we will look at a common method used to retrieve records from the database. In this example, user is a model representing the user's table in the database. The where method is part of Rails query interface, used here to retrieve all users who are 21 years old. It constructs an SQL query behind the scenes, executes it, and returns an active record relation object containing the matching records. This method allows for chaining further queries or directly accessing the results. Scopes. In Rails, scopes allow you to specify commonly used queries, which can be referenced as method calls on the association objects or models. Scopes make it easier to read and maintain code by keeping the query definitions in the model itself and allowing you to use method chaining to combine multiple queries. In this example, 2 scopes are defined in the article model. The first scope, published, filters articles that are published true. The second scope, recent, orders articles by their published at date in descending order. These scopes can be chained together, allowing you to query published articles and sort them by how recent they are with article.published.recent. This demonstrates how scopes can simplify complex queries and improve code readability. Advanced active record, callbacks, polymorphic associations. Callbacks in Rails are hooks into the lifecycle of an active record object that allow you to trigger logic before or after an alteration of the object state. This can be very useful for actions that should happen automatically, ensuring data integrity or performing side effects in your application. In the given code, before save is a callback that is executed before the user object is saved to the database. The normalizeName method is a private method defined within the user class, meant to be called by this callback. It normalizes the name attribute of the user by capitalizing it. This ensures that every user's name is stored consistently in the database, regardless of how the user input was capitalized when it was created or updated. Managing database transactions. Database transactions ensure that a block of code runs under a database transaction, meaning if any part of the operations within the block fails, the entire transaction can be rolled back to the state before the transaction began. This is crucial in maintaining data integrity, especially when dealing with operations that shouldn't be partially completed. In Rails, transactions are usually wrapped around a block of code using active record base.transaction. In the provided code, both the creation of a user and the user's post are wrapped inside an active record base.transaction block. This means that if either the user creation fails, perhaps due to validation errors, or the post creation fails, neither of the database operations will be committed. Instead, an exception is raised. Create method raises an error if the record invalidates any constraints, and the transaction rolls back, leaving the database as if neither operation was attempted. This ensures data consistency, as it wouldn't make sense to have a post in the database without its associated user. Handling HTTP requests. In Rails, controllers are responsible for handling HTTP requests sent by web browsers or other clients. Each public method in a controller is called an action, and these actions are connected to specific routes that determine what method is called for a given URL. Let's take a look at how a simple GET request is handled with a Rails controller. In this code, we have a welcome controller that inherits from application controller. Inside, there's an action named index. When a GET request matches the route pointing to welcome controller index, as configured in the routes file, usually routes.rb, this method is invoked. The @message instance variable is set to hello world, which can then be accessed within the corresponding view for this action to display the message to the user. The process demonstrates a basic flow of receiving a HTTP request, the controller processing that request, and responding with a view. Routing. Routing in Rails is a mechanism that directs incoming web requests to the appropriate controller action. It involves defining patterns to match URLs, extracting parameters from them, and determining which controller and action to trigger. Let's look at a basic routing example. This code defines a route that responds to a GET request for the URL/photos/show. It maps this request to the show action within the Photos controller. When a user accesses this URL, Rails knows to instantiate the Photos controller and call its show method, passing any parameters if available. This is how Rails connects URLs to the logic in the controllers, making web application development more organized and intuitive. Parameters. In Rails, parameters play a crucial role in transferring data between actions within your application. Parameters can come from the query string in the URL, the body of the HTTP request, or the path of the URL, for example, in RESTful routes. Let's explore how to access these parameters within a controller action. In this code, params is a special object acting as a hash, providing access to request parameters. Here, params ID retrieves the id parameter from the request's path. For instance, if the request URL is /books, params id would be 5. This value is then used to find a book in the database with the matching ID. This illustrates how parameters can be used to pass data to a Rails controller action, enabling specific database records to be queried. Sessions and cookies. In Rails, Sessions and cookies are used to store data across requests from a user. A session is used to keep track of user data until the user closes the browser, while cookies can store data on the client's computer to be accessed in future sessions. This code snippet shows how to set a user ID in both the session and cookies. The session line stores the user's ID for the duration of their browser session. The cookies line, on the other hand, sets a signed cookie with the user's ID that expires in 1 year. The signed method ensures that the cookie is secure and cannot be tampered with by the client. Filters: before, after, around. Filters in Rails controllers are methods that run before, after, or around a controller action. They're used to dry up your code by extracting repetitive tasks. For example, you may use them to check if a user is authenticated before allowing them to access certain actions. In the provided code snippet, before action is a filter that sets up a method, authenticate, to be called before the edit and update actions. This method would typically contain logic to check if a user is logged in or has the right permissions. If the user isn't authenticated, you might redirect them or display an error message. The only option limits this filter to only apply to the specified actions, helping control when the authentication check happens. RESTful resources. In Ruby on Rails, RESTful resources provide a conventional way to organize application functionality around resources and standard HTTP methods. This makes design and interaction with resources predictable. Rails makes it effortless to define routes for these actions using the resources method in your routes configuration. The code snippet defines a set of RESTful routes for an article's resource by using the resources method in the application's routing configuration file, typically found at config/routes.rb. This automatically creates routes for standard CRUD, create, read, update, delete actions. It includes routes for showing a list of articles, index, displaying a single article, show, creating a new article, new and create, editing an article, edit and update, and deleting an article, destroy. Each action is mapped to a corresponding controller action. Nested resources. In Rails, nested resources are used to handle cases where a particular resource is logically encapsulated within another resource. For example, if your application has users and each user has multiple articles, the articles are a nested resource within users. This hierarchical relationship is defined in the routing layer. This code snippet defines a nested resource for articles within users in your application's routes. When we use resources articles inside the resources users block, it tells Rails to create routes for articles that are nested within users. The resulting URL patterns reflect this hierarchy, such as users, user IDs, articles, allowing you to construct views and controllers that reflect the nested relationship between users and their articles. ActionMailer basics. ActionMailer is a component of Ruby on Rails that allows your application to send emails. It can be utilized for sending welcome emails, notifications, or any other information via email. Let's create a basic user mailer for sending a welcome email to new users. In this code snippet, we define a class userMailer that inherits from ActionMailer, allowing us to use ActionMailer's functionality. We set a default from email address for all mails sent through this mailer. The welcome email method is defined to accept a user parameter, which represents the recipient of the email. Inside the method, the user is assigned to an instance variable @user and a login URL to @URL, which can be used in the mailer views to personalize the email content. The mail method is then called to actually send the email, specifying the recipient's email address and the subject of the email. ERB and HAML. ERB Embedded Ruby is a templating system that embeds Ruby into a text document. It is commonly used in Rails views to generate dynamic content with .html, .erb, or .arb files. This ERB snippet creates a link using the link-to-helper method, which is a common Rails helper. Here, home is the text of the link, and root path is a Rails path helper that links to the application's root path. The tags and sent tags evaluate the Ruby code within them and include its result in the output HTML. Layouts and rendering. In Rails, layouts and rendering are central to displaying information in your web app. Layouts serve as templates that wrap around your views, providing a consistent structure across pages. Rendering is the process of generating the HTML for your views. Let's explore how to specify a different layout for a controller and how to render a partial. This code snippet illustrates two concepts. First, by declaring layout product only show at the top of the products controller, we specify that the show action should use the product.html.erb layout instead of the default layout. Second, in the index action, we manually specify the layout by calling render layout application. This overrides the controller level layout declaration for the index action, making it use the application.html.erb layout. This flexibility allows for different parts of your application to have distinct visual structures. Partials. In Rails, partials are small, reusable view files used to break up large views into manageable pieces. By extracting repeated code into partials, we keep views dry, don't repeat yourself, and more organized, improving maintainability and readability. This code snippet demonstrates how to render a partial named menu.html.erb within a view. The render method is called with the partial's name, prefixed with an underscore when referring to it in the file system, but the underscore is omitted in the render call. Partials can also be stored in a shared directory for use across different views, further enhancing reusability and organization in your Rails application. Helpers. In Rails, helpers are designed to manage complexity in views by providing methods to perform common or repetitive tasks. This allows you to keep your code dry, don't repeat yourself, and maintain clean views. Let's explore a simple example of a custom helper method that formats dates in a more user-friendly way. This code snippet defines a method formatted date within the application helper module, which is automatically included in all views by Rails. The method takes a date argument and converts it to a string with a format of month, day, year, using the stirf_time method. For instance, if passed a date object representing April 5th, 2023, the method returns April 5th, 2023. You can use this helper in any view to ensure consistent date formatting throughout your application. Forms and form builders. Forms are essential in web applications for gathering user input. Rails provides a powerful form builder helper to streamline the creation of form elements, making it simple to integrate with model objects. This code snippet demonstrates how to create a form for a user model using form with. Form with model @user initializes the form builder tied to the @user instance. Inside the block, form.label and form.text field are used to create labels and text fields for the model's attributes, binding them directly. Form.password field generates a password input, and form.submit creates the submit button. The local true option ensures the form submits via a traditional HTTP request, as opposed to an AJAX request. Using ActionView helpers. In Ruby on Rails, ActionView helpers are methods used to simplify the generation of HTML, forms, and other elements in views. These helpers abstract common patterns to make view templates more manageable and concise. This code snippet utilizes the link to helper, one of the most frequently used ActionView helpers. It generates an HTML anchor, a tag, that links to a path derived from the specified controller, action, and ID parameters. Here, it creates a link to the path corresponding to the show action in the other controller with an ID of 5. The text "click me" is displayed as the clickable link in the rendered view. Using assets, JavaScript, CSS. In Rails, assets like JavaScript and CSS improve the interactivity and style of your application. They are typically kept in the app/assets directories. Rails uses the asset pipeline to minify and compile these files, improving load times for your users. Here's how to include them in your application. In the CSS file, the require tree directive tells Rails to include all CSS files in the app/assets style sheets directory. Similarly, require self tells Rails to include CSS styles defined within the application.css file itself. For JavaScript, require jQuery includes jQuery in the application, assuming it's been added to the project's gem file or via another method. Require tree functions the same here, including all JavaScript files in the app/assets JavaScripts directory. This setup ensures that all styles and scripts are automatically compiled and included in your Rails application, improving the development experience and site performance. Webpacker and managing JavaScript CSS. Webpacker is a popular tool in Ruby on Rails used to manage and bundle JavaScript, CSS, images, and fonts. It leverages Webpack, the JavaScript module bundler, to achieve this. Incorporating Webpacker allows for a modern JavaScript workflow within Rails, enabling features like ES6 syntax, JSX, Vue.js, Angular, and CSS preprocessors. In your Rails application layout, you use the JavaScript pack tag and stylesheet pack tag helpers to include the JavaScript and CSS bundled by Webpacker. The application argument corresponds to the main entry points for your JavaScript and CSS, typically found within the app/javascript/packs directory. This code ensures that your compiled resources are correctly referenced in your HTML layout, enabling your Rails app to utilize the assets processed through Webpacker. Integrating HTML CSS frameworks, e.g. Bootstrap. Integrating frameworks like Bootstrap into a Rails application enhances the visual aspects without extensive CSS coding. Bootstrap offers ready-made components, making responsiveness easier to implement. This is achieved by including Bootstrap's files into the Rails asset pipeline. First, the Bootstrap gem is added to the gem file and bundled. The application.scss file, which is part of the asset pipeline, then imports Bootstrap by using @import-bootstrap. This makes Bootstrap's styles available throughout the application, allowing you to utilize its classes directly in your HTML files for styling. Using JavaScript with Rails. Integrating JavaScript with Rails enhances the interactivity of your applications by allowing client-side scripting. Rails facilitates this integration through Webpacker, which manages JavaScript code and assets, enabling you to include modern JavaScript frameworks and libraries seamlessly. Here's a simple example of how to use JavaScript to dynamically update a page without a full reload. In this code snippet, we first ensure the DOM is fully loaded by listening to the DOM content loaded event. Then, we find an element with the ID myButton and attach a click event listener to it. When myButton is clicked, the content of the element with the ID myDiv is updated to display a new message. This demonstrates a basic interaction pattern in a Rails application, where JavaScript directly manipulates the DOM based on user actions, offering a more dynamic and responsive user experience without requiring a page reload. Introduction to Webpack and Yarn. Webpack is a modern JavaScript application bundler that allows you to bundle your JavaScript, CSS, and assets. Yarn is a package manager that doubles down on speed, reliability, and security. Together, they help in managing dependencies and assets in a Rails application efficiently. This command installs Webpack and Webpack CLI command line interface using Yarn into your project. Webpack is used to compile JavaScript modules, while Webpack CLI provides a flexible interface for running Webpack commands. By adding these packages, you enable your project to use Webpack for asset bundling. Turbolinks. Turbolinks is a library included with Ruby on Rails that makes your application's navigation faster by using Ajax to load pages. This means that most of the page, like the header and footer, doesn't reload, only the main content does. Here's how you can ensure your JavaScript code runs properly with turbolinks. This piece of JavaScript ensures that your code runs after turbolinks finishes loading a new page. Normally, JavaScript runs only when the page is fully loaded. However, because turbolinks doesn't reload the entire page, the load event won't trigger again unless you navigate to a completely new page. By listening to the turbolinks load event, you make sure your JavaScript initializes or executes each time turbolinks loads a new page, making your application more responsive and efficient without the need for a full page load. Stimulus.js. Stimulus.js is a modest JavaScript framework introduced by Basecamp, designed to augment HTML with additional functionality by connecting DOM elements to JavaScript objects seamlessly. It focuses on enhancing server-rendered HTML with minimal overhead, making it an ideal fit for Ruby on Rails applications looking to sprinkle interactive features without committing to a single-page application architecture. In the provided code, we define a Stimulus.js controller for a simple greeting functionality. The controller imports the base controller class from Stimulus. It then declares a target name, which is a reference to an HTML element marked with a data target attribute. The greet method, when invoked, grabs the value of the name input field, inserts the value into a greeting message, and then displays it using an alert box. This illustrates how Stimulus.js allows for clean organization of behavior directly related to the HTML structure, keeping the JavaScript tidy and focused. React.js integration. Integrating React.js with Ruby on Rails allows for creating interactive user interfaces within a Rails application. This setup enhances the application's responsiveness and user experience. We'll use the React Rails gem for this integration, enabling React components to be embedded within Rails views. The code snippet begins by adding the React Rails gem to the gem file, which is necessary for integrating React.js into a Rails application. After adding the gem and running bundle install, the Rails generate React install command is executed. This command sets up the React environment within the Rails application by adding the necessary JavaScript files and folders. It also updates the application.js file to include React as part of the Rails asset pipeline, ensuring that React components can be compiled and served with the rest of the application's assets. Vue.js integration. Integrating Vue.js with a Ruby on Rails application can greatly enhance the user interface and interactivity of your application. This integration allows you to leverage the power of Vue.js within your Rails views. The example below demonstrates how to set up Vue.js in your Rails application, assuming Vue.js has already been installed using Webpacker. In this snippet, JavaScript pack tag hello Vue is used to include the Vue.js application packaged by Webpacker. The div id equals app tag defines where the Vue.js app will mount. Inside it, message binds the message data property of the Vue instance to the DOM. The script defines a new Vue instance, specifying the mount point with il.app and initializing message in the data object. This setup displays hello Vue on the page, showing a basic example of how Vue.js can be integrated into a Rails view for dynamic content. Introduction to testing. Testing is a crucial part of development in Ruby on Rails, allowing developers to ensure their code works as expected before deployment. Rails supports several testing frameworks, but will focus on the built-in mini-test framework. Let's start with a simple test example for a model. In this piece of code, we define a test case for our article model inside the article test class, which inherits from active support test case. The test method is used to define our actual test, named should not save article without title. Inside this method, we instantiate a new article object without a title and attempt to save it. The assert not method is used to ensure that saving the article returns false, as our validation should block saving an article without a title. This demonstrates a simple test to check model validations. TDD/BDD concepts. Test-driven development (TDD) and behavior-driven development (BDD) are methodologies that aim to improve the quality of software by involving testing at every stage of the development process. In TDD, developers first write failing tests for the feature they wish to add or the bug they want to fix. They then implement the smallest amount of code needed to pass the tests. In BDD, the focus is on the behavior of the software, with tests written in a way that describes how the application should behave from the perspective of the end user. In the provided code example, we're demonstrating a simple BDD approach using RSpec and Capybara in a Rails application. This test specifies how the homepage of a web application should behave from a user's perspective. The describe block outlines the feature being tested, the homepage. The it block contains the actual test, which in this case checks that when a user visits the home page, they are welcomed with the text welcome. It's a behavior-focused test, making sure that the user's experience is as expected. This is a BDD approach because it starts from the outside in, focusing on the user interaction with the application. Unit testing with RSpec. Unit testing plays a fundamental role in the development process, particularly in Rails applications. RSpec is a popular testing framework in Ruby because it provides a readable and expressive syntax for writing tests. In this example, we'll focus on creating a basic unit test for a model in a Rails application using RSpec. The code starts by requiring the Rails helper file, which includes the configurations and custom matches needed for our tests. We then describe a test suite for the user model. Inside, we define a context for validation tests, which helps us organize tests of similar nature or scenario. We use it to define an individual test case, describing what the test is expected to do, which in this example checks if a user without an email address fails to save. The user variable attempts to save a new user instance without an email, and we expect this operation to return false, indicating the user hasn't been saved due to failed validations. Integration testing with Capybara. Integration tests in Rails help ensure that various parts of your application work together correctly. Capybara is a popular tool used for integration testing with Rails, allowing you to simulate user interactions with your web pages. Let's explore a simple example where we test user registration on a website. This test script uses Capybara with RSpec to simulate a user signing up with a valid email and password. Initially, we require Rails helper to include the necessary setup for Rails testing. We define a feature test called user signs up and describe a scenario where the user provides valid credentials. The test visits the registration page, fills in the email and password fields, and submits the form. It then verifies that the page contains a welcome message, signaling a successful sign-up. This test helps ensure the registration process functions as expected from a user's perspective. Factories and fixtures. Fixtures allow you to populate your testing database with predefined data before your tests run. They are written in YAML and can be found in the test fixtures directory of a Rails application. In the users.yml fixture file, we define a user with a name of John Doe and an email of john@example.com. Rails will use this data to create a user record in the test database before the tests are run. You can then refer to this user in your tests using users John Doe. Mocking and stubbing. In testing, it's often necessary to isolate the piece of code you're testing from external systems or complex logic. This is where mocking and stubbing come into play. Mock objects simulate the behavior of real objects, and stubs replace parts of your application with code that returns predefined responses. They are particularly useful for unit tests where you want to test components in isolation. In this Ruby code snippet, we're using a stub to simulate a method response. Allow is used to set up the stub on the user object. This tells the test to expect the name method to be called on the user object, and whenever it is, to return John Doe as a predefined response. This allows us to test functionality that depends on the user's name without needing to create a real user or rely on a database. It simplifies the test setup and makes the tests faster and more reliable. System testing. System testing in Rails allows developers to test the application from the user's perspective by simulating real user interactions in a browser. This ensures that the full stack of the application, including its JavaScript functionality and the front end, works correctly. Rails uses Capybara for system testing, providing a powerful DSL for describing user interactions. This code snippet demonstrates a simple system test in Rails. It inherits from application system test case, which sets up the test environment for system tests. The test, named visiting the index, navigates to the posts index page by using visit posts URL. It then asserts that there is an h1 element with the text posts, ensuring the posts page is rendered correctly. This test mimics a real user visiting the posts index page and verifies the presence of expected content, showcasing how system tests contribute to testing the user-facing parts of the application. Continuous integration, continuous deployment, CI/CD basics. Continuous integration, CI, and continuous deployment, CD, are practices in software engineering designed to improve code quality and streamline the deployment process. CI involves automating the integration of code changes from multiple contributors into a single software project, which often includes running automated tests. CD automates the delivery of the application to selected infrastructure environments. We'll install a popular CI tool, CircleCI, for a Ruby on Rails project. This configuration snippet is for CircleCI, saved as a .circleci/config.yml file in a project's root directory. The version specifies the CircleCI platform version, which determines the syntax and processing features. Orbs serve as reusable snippets. Here, we're using a predefined orb for Ruby to simplify our setup. Under jobs, a build job is defined, using a Docker image of Ruby 3.0. The steps dictate the actions taken during the CI process, checking out the code from the repository and installing dependencies with Ruby install deps. Lastly, workflows orchestrate the execution of jobs. Build and test specifies that the build job will run, allowing for additional jobs like test to be easily added. API-only applications. In a world where front-end frameworks like React, Angular, and Vue are becoming increasingly popular, Rails has adapted by providing the ability to create API-only applications. This means that Rails can be used to build back-end applications that serve JSON data to be consumed by client-side frameworks or other applications. This approach simplifies the generated middleware stack to only include components essential for API functionality. The command shown creates a new Rails application configured for API-only usage. By adding -API, Rails skips middleware and modules that aren't necessary for serving APIs like views and assets pipeline. Moreover, it configures generators to skip views, helpers, and assets when scaffolding a new resource. This makes the app lightweight and optimized for API responses. Background jobs, Sidekiq, Resque. Background jobs in Rails are tasks that can be executed outside of the main thread of a web application, allowing for long-running tasks to be handled asynchronously. This is essential for operations that would otherwise block the server, like sending emails or processing files. Sidekiq and Resque are popular Ruby libraries for managing background jobs. They use Redis as a storage backend for the job queue. Here, we'll focus on setting up a simple Sidekiq worker. In the code snippet, we define a class hardWorker that includes the Sidekiq worker module. This inclusion is what tells Sidekiq that this class represents a worker that can execute tasks asynchronously. Inside the worker class, we define a perform method. This method is what Sidekiq will call to execute the background job. It takes parameters, in this case name and count, which can be used within the method to perform whatever task is necessary. The body of the perform method represents the long-running task, here simulated by a puts statement indicating the work being done. This structure allows for any heavy lifting to be offloaded from the main application thread, improving the scalability and responsiveness of a Rails application. File upload, active storage, carrier wave. Active storage simplifies the process of uploading files to a cloud storage service like Amazon S3, Google Cloud Storage, or Microsoft Azure Storage, and attaching those files to active record objects. It comes with Rails, so there's no need to add a gem for this functionality. Let's walk through a basic example of attaching an image to a user model. In this code snippet, we're extending the user model to include one attached file, which we're calling avatar. By adding has one attached avatar, we enable active storage for the user model. This allows us to attach an image file directly to a user record. Active storage handles the file uploading process, including saving file metadata in the database and the file itself in the specified storage service. This provides a streamlined way to manage file uploads without having to deal with the intricacies of file storage and retrieval. ActionCable and WebSockets. ActionCable is a Rails framework that integrates WebSockets with the rest of your Rails application. It allows for real-time features such as chat, notifications, and live updates. WebSockets provide a persistent connection between the client and the server, enabling both to send data at any time, which is a significant shift from the traditional request-response cycle. The code defines a new channel, chat channel, which inherits from ActionCable channel. The subscribed method is called when a client subscribes to the channel, establishing the subscription to chat channel. The speak method is an action that receives data, in this case a message, from the client and broadcasts it to all subscribers of the chat channel. This demonstrates how ActionCable facilitates real-time communication by broadcasting messages to all connected clients. Internationalization, I18N. Internationalization, often abbreviated as I18N, is a process that makes your application adaptable to different languages and regions without engineering changes. Rails provides a straightforward I18N API that you can use to internationalize your application. In this code snippet, i18n.locale=dd sets the current locale to German. The i18n.thello translates the keyword hello based on the locale. It looks up the translation in the locale files under the config/locales directory. If your application supports multiple languages, you'd have separate files for each, like en.yml for English and de.yml for German. These files contain translations of strings used in your application. The translation for hello would be provided in each of these files, enabling the application to display the appropriate translation based on the selected locale. Security best practices. Security is paramount in web applications. Ruby on Rails offers several built-in mechanisms to protect your applications from attacks such as SQL injection, cross-site scripting, XSS, and cross-site request forgery, CSRF. Understanding and implementing these security features is crucial. The code snippet showcases the use of strong parameters, a security practice to prevent mass assignment vulnerabilities. By specifying permit name, email, it ensures that only the name and email fields can be updated through mass assignments, protecting other attributes from malicious modification. Performance optimization. Performance optimization in Ruby on Rails is about enhancing the speed and efficiency of your Rails application. It involves various techniques to reduce the load time and improve the responsiveness of your app. This example demonstrates how to optimize database queries using the .includes method, which helps to reduce the number of queries by preloading associated records. In the provided code, the .includes author method is used in the books controller's index action. When fetching books from the database, it'll preload all associated authors in a single query. This approach prevents the n+1 query problem, which occurs when fetching each book's author requires an additional database query for each book. As a result, if there are 10 books, instead of making 11 queries, one for all books, plus one for each book's author, the .includes method ensures that only 2 queries are made, one for all books and another for the associated authors of these books. This substantially reduces the database load and improves performance. Deployment, Heroku, AWS, Docker. Deployment is a crucial step in web development where the application is made available on the internet. We will cover basic deployment strategies using Heroku, AWS, and Docker. Heroku provides a straightforward, managed platform for deploying Rails apps. AWS offers more control and scalability, but requires a steeper learning curve. Docker, on the other hand, focuses on containerization, allowing your application to run in any environment. This command is used for deploying a Ruby on Rails application to Heroku. It requires that you have a Heroku account, have created an application space on Heroku, and configured Git to push to Heroku. First, ensure your application is committed to a Git repository. Then, by executing git push Heroku master, your application code is pushed to Heroku, which will then automatically build or compile the application, detect the necessary dependencies, and deploy it so it's accessible over the web. Remember, Heroku dynamically assigns your application a URL, but you can also configure a custom domain. Code structure and organization. In Ruby on Rails, maintaining a clean and organized codebase is crucial for readability and maintainability. This includes adhering to convention over configuration, segregating code logically, and utilizing Rails' structure efficiently. This code snippet demonstrates a well-organized model following Rails conventions. First, associations are defined to establish relationships with other models. Next, validations are set to ensure data integrity. Then, callbacks are used for pre-processing data. Structuring code this way enhances readability, making it easier to navigate and understand the model's functionality. Keeping each section organized and adhering to a consistent format across models aids in maintaining a clean codebase. Dry, don't repeat yourself, principle. The dry principle is a fundamental concept in software development, advocating for the reduction of repetition within code. In Ruby on Rails, adhering to dry helps keep your application's codebase more maintainable, scalable, and less bug-prone. Let's examine a simple example where dry can be applied to improve a Rails application. In the provided code, the string interpolation of hash, first name, last name is repeated in both the full name and greeting methods within the user model. This violation of the dry principle means that if the way a user's full name is displayed changes, the developer must remember to update it in multiple places. A dry approach would involve extracting this repeated logic into its own method, and then calling that method wherever the full name is required. By doing this, changes to the user's full name formatting would only need to be made in one place, reducing the potential for bugs and streamlining future updates. Refactoring techniques. Refactoring is a crucial aspect of software development aimed at improving code readability and efficiency without changing its behavior. In Rails, it involves adopting more concise and expressive Ruby and Rails conventions to take full advantage of the framework's features. This example demonstrates a common refactor in Rails controllers, streamlining the retrieval and filtering of records. Initially, all books are fetched from the database. If a category parameter is provided, the collection is further filtered by that category. This pattern is efficient and adheres to Rails' skinny controller, fat model best practice by keeping the controller action concise. However, to further refactor this for cleanliness and encapsulation, the filtering logic can be moved into the model or a query object, making it more reusable and testable. Version control with Git. Version control is essential for tracking and managing changes to software code. Git, a free distributed version control system, is particularly effective for collaboration, allowing multiple developers to work on the same project without interference. Rails projects can greatly benefit from Git, ensuring all changes are traceable, reversible, and collaborative. The code snippet initializes a new Git repository with git init, which prepares your Rails project for version tracking. Git add stages all changes in the project directory, making them ready for a commit. Finally, git commit add initial commit securely saves the staged changes with a message describing the commit. This fundamental process sets the stage for ongoing version control, enabling developers to track and revert changes as necessary. Code reviews. Code reviews are a systematic way of examining another team member's code. This process helps maintain a uniform code quality, encourages knowledge sharing, and spots bugs before the code goes into production. The code block represents the typical workflow of a code review process. Initially, the developer reviewee submits a pull request. The reviewer, then, evaluates the code against several criteria such as coding standards, security vulnerabilities, and performance issues. Discussions about potential improvements may take place in the form of comments on the pull request. Finally, after satisfactory revisions, the code is merged into the project. This practice not only improves the quality of the software, but also facilitates knowledge exchange among team members. Debugging techniques. Debugging is a crucial skill in web development, allowing you to identify and resolve issues within your application. Ruby on Rails offers several techniques to streamline this process. Here we'll explore using the ByBug gem, a powerful tool that allows you to pause your code execution and interact with your program's environment at any point. In the code snippet, ByBug is inserted before the action we wish to inspect. When Rails reaches this point, it pauses, and you're dropped into a debug console. From here, you can inspect variables, e.g., examining X will reveal its value as hello, step through code line by line, and continue execution. This ability to pause and examine the state of your application at specific points is invaluable for diagnosing problems and understanding how your code behaves in real time. Logging and auditing. In Rails, logging and auditing are crucial for tracking user activities and understanding the flow of transactions within an application. Logging involves recording informational messages about the application's operation, while auditing focuses on tracking changes, typically in the form of user-driven data modifications. Here, we'll demonstrate a simple way to implement auditing by logging model changes. This example shows a user model equipped with an after-commit callback. The log changes method is triggered after a new user is created or existing user data is updated, but not on destroy actions. Within log changes, we use rails.logger.info to write a log message that includes the user's ID, whether the record was created or updated, and the changes made, excluding the updated at field for clarity. The previous changes method, available in any active record model objects, returns a hash of the changes made during the last save or update, making it a perfect fit for auditing purposes. This way, we achieve a simple, yet effective method of logging and auditing changes to the user model. Community and resources. The Ruby on Rails community is known for its enthusiasm and support. There are numerous resources available for new and experienced developers alike. From official documentation to community forums and interactive platforms, these resources can help solve specific issues, learn new techniques, and stay updated with the latest trends in Rails development. The provided code illustrates how one can specify the Ruby on Rails version in a gem file. This is a fundamental step in ensuring your Rails application uses the correct version of the framework. It's an important practice because the Rails community frequently releases new versions, each offering improvements, new features, and security patches. By specifying the version, developers can take advantage of the extensive documentation and community support tailored to that specific version of Rails. This example underlines the importance of being precise with your development environment to leverage community resources effectively.